Good morning, everyone. Welcome to Software Engineering. I'm Zhang Shuang from Software College, Northeastern University. Well, we are learning Chapter 1, Introduction to Software Engineering. This point is software crisis. From the previous lectures, we have understood that we are surrounded by software. That means we use software every day. From the experience of software using, we know that sometimes software will fail. Almost all of us have experienced some software failures, such as Windows failure, or Word failure, or maybe sometimes we just fail to access some websites, and so on, right? So we must admit that sometimes there's really something wrong with software. Well, this diagram shows the data that have been collected by some American statistics of the outcomes of over 9,000 development projects completed in 2004. Okay. From this diagram, to our surprise, that we learned that not all software are successful. Actually, there are only 29% projects are successful. Well, and 19% projects are cancelled. And more than half projects are late and over budget. So that means the truth is that nowadays our software are of low quality, and it over budget and is not delivered on time. So the things are not as successful as we thought or as we expected. Okay. So that means software industry has got some problem, has encountered some difficulties. Generally speaking, the main manifestations of software crisis include the following issues. First, estimation of cost and price is usually inaccurate. Actually, we have understood that software is abstract, and it is totally different from other physical concrete entities. Maybe it's much easier to estimate how long and how much will a building cost, or will a bridge cost, and so on. But it is really very hard and difficult to estimate cost and the process or duration of a software development. There is no formula so far. Okay. So most of the time, people just estimate based on their own experience. So that's why estimation of cost and process is usually inaccurate. And next, the user is unsatisfied with completed software system. Even though the software organization has delivered the completed software to the users and client, but most of the time, the client and the users are not satisfied. Some functionality just fail, and some functionality may be missing, and so on. Software quality is usually unreliable. Just now we have given some examples of software failures, such as Windows and Office, Word, and so on. We know that Windows and Office are developed by Microsoft, and Microsoft is the #1 software organization. So you can imagine how the quality is, even it is delivered by the #1 software organization. Okay, so software quality is usually unreliable. And next, software is unmaintainable. The reason is that first, software itself is complex, and second, the problem that the software is trying to solve is complex. Okay. And also because most of the time no documentation is available. Okay. Because many software organizations think that software development is just coding. So they don't think documentation is available. So that means finally, no field documents will be available for maintenance. And software takes more and more proportions of the total cost of computer system. There are two reasons. The first reason is because hardware is becoming cheaper and cheaper. Although I understand that the hardware is developing so fast, much faster than the development of software. So hardware is taking less and less proportions of the total cost of computer system. And the next reason is that nowadays software is trying to solve more and more complex problems. Okay. So that's why software is taking more and more proportions of total cost of computer system. Well, software development does not match the rapid and deeper and wider computer applications. Since hardware is much cheaper than before, okay, so many organizations and many personal individuals are using software nowadays for working, for studying, for amusing, and so on. We must admit that the software does not develop as fast as the hardware. So that means there is still a long way for software to go. Okay, so far we have talked quite a lot about software crisis. When we talk about the software crisis, maybe somebody will think about engineering in other areas, okay, such as bridges. Let's say if a bridge collapses, okay, it must be the top news in the following a few days. But when seldom see the top news or even just normal news about the failed operating system. Why? Because people are taking different engineering principles for the normal engineering and the software engineering. Okay, so in 1968, AATO Software Engineering Conference was taking place. During the conference, computer and software experts had discussed about software crisis. The every experts admit that software is really experiencing crisis, okay? And the solution should be software engineering. That means software should also be taken as engineering, just the same with other engineering in different domains. That means the software development is not the mysterious technique of a certain individual labor, but should be the engineering organization of all kinds of persons. So software engineering studies exactly how to develop and support a computer software. So I guess now you understand why there's a major of software engineering and why there's a domain of software engineering, right? Okay, so I hope you understand more about the software engineering and more about your major, more about your future professionals so far. Okay, so much for software crisis.